Let's talk about the periodic table of elements. Sean with Create Your Lifestyle Academy, and in this episode of Beyond the Bonds, we are going to do just that. We have been talking about atoms and subatomic particles, namely the proton, neutron, and electron. We know that each element has different amounts of subatomic particles, but just how many elements are there? How can we organize the vast amount of elemental information that exists and get information that will be useful to us? And the answer to these questions lies in the periodic table of elements. Let's expand on this. In the periodic table app accessed via my iPhone, it is seen how the elements are arranged. The protons account for the identity of each element. The neutrons are also included in the nucleus, and the electron distribution indicates where we are likely to find each electron. The electrons being located in either orbits or orbitals, depending on whether you adopt the Bohr model or Schrödinger model. So, the first thing I want to point out on the app is that the columns are groups and the rows are periods. And these can be used to identify certain trends in elemental properties as well as how the electrons are expected to behave. Beginning with the columns / groups, of which there are 18, we know for certain that there are certain characteristics associated with 8 out of the 18. The middle portion being more varying. The first group is known as the alkali metals. The second group is known as the alkali earth metals. The middle chunk of the periodic table contains the transition metals. Group 13 are classified as the post-transition metals, excluding boron. The metalloids, which have characteristics of both metals and nonmetals, go diagonally from boron to polonium. The nonmetals are hydrogen, carbon, etc. The halogens are group 17, and the noble gases, which do not react at all, are group 18. A lot to take in, so I've included a link in the description that describes these classifications for you all. I want to bring your attention to the hydrogen picture that you see on your screen. It explicitly says hydrogen. The one that you see in the bottom left corner represents the atomic number, which indicates how many protons there are in the element. If we were to have boron, that number would be 5, indicating that there are indeed 5 protons in the element. The number that you see on the bottom right of the hydrogen box is the mass number, which accounts for how many atomic mass units that hydrogen has. It accounts for how many protons and neutrons there are. So hydrogen only has 1 proton. It does not have a neutron. Lastly, let's discuss how the periodic table visually represents the electron distribution. Columns 1 and 2 have their valence electrons, the electrons on the outermost ring in the s orbital. Groups 3 through 12 have their valence electrons located in the d orbital. Groups 13 through 18 have their valence electrons located in the p orbital. The elements on the 2 rows at the bottom of the periodic table have their valence electron located in the f orbital. Without giving too much away, the arrangement of the elements on the periodic table indicates which elements are willing to combine together, and in subsequent videos we will see how. Simply put, the world of elements is not enough.